Good morning. Thank you for joining. My name is Anika McGovern, and I am the Sustainability Manager for Jarden. First, a bit of housekeeping. Please feel free to explore the conference website. Under the Info tab, you'll find the conference agenda, presenter biographies, and company profiles. There is also a Q&A function throughout all the presentations today and tomorrow. We encourage you to type your questions here, and each host will ask them on your behalf. As Robbie mentioned in his welcome address, I am pleased to be able to introduce Dr. Kevin Trenbert, a distinguished scholar and at the National Center for Atmospheric Research and an honorary academic in the Department of Physics at the University of Auckland. Kevin has been very prominent in the Intergovernmental Panel on Climate Change and the World Climate Research Program. He is a fellow of the American Meteorological Society, the American Association for Advancement of Science, the American Geophysical Union, and honorary fellow of the Royal Society of New Zealand. He's published over 570 articles and books and is one of the most cited scientists in his field. He also has a new book coming in December where Decarbonisation is a part of one of the chapters. He is joining us today from Auckland's North Shore, where he has been based for the past 2 years after 43 years in the United States. Kevin, thank you so much for joining us today.
Thank you very much, Anika. I'm a climate scientist. I'm not a business person. I am not a representative in New Zealand. And I'm going to talk to you today about climate emissions and a little bit about climate. So some key things in this presentation is I'm going to start from a global perspective and deal with carbon dioxide, move to methane, and then zoom in a little bit on Australia and New Zealand, and in particular on New Zealand aspects. And so right from the start, I'm going to assume that you recognize that we have a problem, and carbon dioxide has increased by 48% from pre-industrial levels. This is mainly from the burning of fossil fuels. Carbon dioxide is a greenhouse gas. That's very clear. It produces, therefore, what is called global warming, and I'll say more about that in a minute. And the climate is changing. And so global warming really is global heating, although most commonly it refers to the global increase in surface temperature. However, the heating from the increase in carbon dioxide does indeed contribute to increases in surface temperature, but it also contributes to increases in surface evaporation, which dries things out, creates drought and heat waves. It also puts more moisture into the atmosphere, therefore, and that gets caught up in storms, and it rains harder and leads to risks of floods. It leads to stronger storms as a consequence. In addition, there is melt going on in Greenland and Antarctica and glaciers. And so global heating is one of the reasons we have all of these increases in extremes that we see around the world recently. So this is the carbon dioxide record from Mauna Loa, from actually a very good friend of mine, Dave Keeling, that was set up in 1958. And the first thing he noticed with it is that there was a strong annual cycle. That's the breathing in and out of the planet, if you like, through photosynthesis in the Northern Hemisphere spring and summer, which draws down carbon dioxide, and then the decay of leaves on the forest floor and wood and so on puts more carbon dioxide back in. But that annual cycle is dwarfed by the overall rising trends. And I want to emphasize that these are increasing. And so we see the rate at the beginning of this record in 1950s, then an increase, a further increase, and then another increase. And you'll see that this increase continues, and the rates in the last few years have been higher than at any time previous. And that includes during the pandemic. And although there are reports that there are decreases in carbon dioxide from fossil fuels it has been made up for by other aspects, such as the bushfires in Australia and the wildfires in other places. And so carbon dioxide is going relentlessly upwards. We need to cut emissions. And so this is the estimate from NOAA of the global mean surface temperature record. It has a certain raggedness to it. The raggedness is a bit greater in the earlier part of the record. And before 1958, the International Geophysical Year, we didn't have observations over Antarctica or the Southern Oceans. And so part of the raggedness earlier on is due to incomplete records. But the highest values on all of this are due to El Nino events. And so the warmest year on record is 2016. I've also put on here an estimate of the pre-industrial level, and you'll see that we've increased by 1.1 degrees Celsius. Then we can add the annual values of carbon dioxide, and before 1958, here we're using the values of estimates from bubbles of air in Antarctica and Greenland. And I've also put the pre-industrial level on here of 280 parts per million by volume, and now we're up over 415. And so this is where this 48% increase comes from. And half of this increase has occurred since 1985, so this is where we have all contributed to it. So the Intergovernmental Panel on Climate Change recently released a report called AR6, the sixth such report. And these are the headline statements: that recent changes in climate are widespread, rapid, and intensifying, and unprecedented in thousands of years. And unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions, this topic today, limiting warming to 1.5 degrees C will be beyond reach. In addition, it is indisputable that these increases are caused by human activities. And this makes the climate events, including the ones listed there, more extreme. And that's what I mentioned earlier with regard to global warming. And then the climate change is already affecting every region of the Earth in multiple ways. In other words, it's not just global small events. And we're experiencing, we will continue to experience these with further warming. So all of those things were actually known by scientists more than 20 years ago, and now they're just more definite. So the relationship between carbon dioxide and the mean surface temperature, which I showed on that previous graph, relates especially well when we deal with the cumulative carbon dioxide emissions. And this is what gives rise to the concept of net zero. In other words, it's only by getting to net zero emissions that we can reduce or cut down on the global mean surface temperature record increases, and presumably on other aspects of global warming. And so we have to decarbonize the energy system. Now, an estimate here is that we have about 500 gigatons left that we can emit before we get to 1.5 degrees C, and that gives us about 7 more years. That takes into account 2020, because the numbers here are for the 4 years up to 2019. And then for 2 degrees C, we have about this much that we can emit, and that gives us about 32 years. So by order 2030, we're at 1.5 degrees C at the current rate, and we can get to 2 degrees C warming by about the early 2050s or thereabouts. So when we look at emissions, we can break that down into different components. We can break it down into the emissions per unit of energy, called the carbon intensity, the energy per GDP, which is the energy intensity, how efficient we generate energy. And then we have to include the GDP per capita and the population, the actual capita. And down below, I've got the overall increases that have occurred in time in terms of the emissions. And then we can also break the emissions down into simply the emissions per capita times the population. And of course, this is one which countries like China really like, because they have a very large population, and so the emissions per capita look pretty good, but it's only the emissions which matter for the climate system. So down below, I'm showing the 2018 values of emissions and the cumulative value. So this is the one which matters most in terms of the overall climate system. And you can compare these to see which countries have sort of reduced compared with their historical values, like the United States, and which ones have increased, like China and India. India is now number 3. Australia is combined with Canada over here, similar amounts per capita, and New Zealand is down here with the other Pacific nations. And so you can see which regions of the world are increasing and which are most responsible for the warming that we have, the climate change that we have. And so here's the overall graph of the increases, and we can blow up the values for the 5 countries that I have examined in much more detail. China, the United States, for obvious reasons. China, the largest emitters now. United States, most responsible overall. And also I included European country, Germany, and Australia and New Zealand. And you can see that the emissions in the United States have dropped in recent years. This is largely because of switching away from coal to more natural gas. This is a map of the actual emissions around the world in 2019. So you can see the dominance of China there. And then this is the cumulative emissions. And so here we see the United States standing out, but you can see very strong emissions from Siberia, from Russia, and also China there, and India is beginning to show up strongly. Australia is quite strong as well. And here's the emissions per capita, and Australia shows up quite strongly here. The strongest is actually Mongolia, which has a very large amount of coal, and of course is adjacent to and coupled to China in a way. And so in terms of the overall contributions from Australia and New Zealand, that's given at the top here. You see Australia's been increasing. This is the percentage of the total now, a different metric. And then down below, I've got the intensity of the emissions, and you can see New Zealand has been doing better or in terms of improving at least the generation of the use of the emissions. I don't have time to spend on this as much as I would like, but at the top here, I've got all of these kinds of metrics in 1990, and then in 2016, which was the last year I could get data for all of these aspects. And you can see the changes from 1990 to 2016, and I've highlighted the ones which have increased. You can see that Germany has decreased, and there have been increases over here. And so Australia is now in this group actually leading the way in terms of the total emissions per capita. There's a lot of other interesting things in here, and generally the carbon intensity has decreased, and the efficiency with which we generate energy per GDP has decreased, and you can see where Australia and New Zealand sit relative to these other countries. And New Zealand is doing well here, but maybe not so well over here. And there's some other interesting things on here about the actual GDP per capita, and also, of course, the population. And you can see that Germany has perhaps made the biggest changes. So then we can look at the effects of trade of goods. This is one of the things which I suspect will be negotiated a lot in Glasgow at COP26. In Australia, there is a net export of carbon dioxide, especially through things like the production of red meat. And New Zealand actually imports carbon dioxide, for instance, goods from China. And China exports carbon dioxide, and the United States is a big importer of stuff from China. And so how do you attribute that? How do you account for that in blaming who is responsible? This is one of the tricky things that we can talk more about later, perhaps. And so I've put these questions up here in terms of what happens if country A, maybe Australia, exports 200 megatons of coal to country B. Maybe country B is China, and country B burns it to produce electricity and then uses that electricity to produce export goods to country C, which might be the United States. And then country C has imported those goods. So who is responsible for that 200 megatons of emissions? Now, I have my answer to that, but I'll address that in the question time if it comes up. So in New Zealand, if New Zealand grows a tree and then the log is exported, who gets debited with the carbon dioxide from its use? And again, that's a good discussion point. So with regard to emissions, here I've highlighted the values from Germany, and Germany's emissions have declined by a startling amount, but a lot of it was because of the transition from West Germany and East Germany combining, and then the closure of a lot of inefficient East German industrial aspects. And so they got a head start over many other places. And there's a number of other comments here, but Germany's done very well on aspects of renewable energy and even solar. And in a place that's as cloudy as Germany is, I think this has some lessons for New Zealand that, we could do a lot better here in New Zealand in that regard. In terms of New Zealand, of course, one of the interesting things in New Zealand is that a lot of electricity here, 84% in 2018, was generated through renewables, mainly through hydroelectricity, a little bit through geothermal. And New Zealand has a relatively large contribution from methane from agriculture. But New Zealand's emissions per capita of carbon dioxide are comparable to other places. And this is something we surely could do a lot better on. Then turning to Australia, now Australia still generates an astonishing amount to me, 66% of its electricity through coal. And I say astonishing because you've got a big desert in the middle and lots of sunshine, which is underutilized, although it's growing. There's a lot of agriculture and fugitive emissions of methane, and there's some details there. I can't. I have to change this a little. And Australia is the largest exporter of coal in terms of dollars, and this is going to become a big issue for Australia. Even today, the latest news from COP26 is that Europe is going to put tariffs on goods that come into Europe, and this includes from Australia, unless there is an accounting for that through some kind of a tax in Australia. And so then, where does that tax money go to? Does it go to Europe or does it go to Australia? Good discussion points. And so the Australia is actually the highest per capita carbon dioxide emission if you include these exports. And so that's a good discussion point, perhaps. So turning to methane, methane is a very powerful greenhouse gas, but it has a relatively short lifetime, much shorter than carbon dioxide. Carbon dioxide is centuries, and about 9 years for methane. And so it's about 86% more potent over a 20-year time frame, and 28 times more potent over 100 years. It's also increased an extraordinary amount, and the biggest increases in recent times are because of fracking. And so these are the contributions to methane emissions. I won't dwell on them here, but point out that methane forms naturally in boggy areas, marsh gas, and it also comes out of things like rice cultivation, and about 60% are man-made, and the production of coal, gas, and oil contributes substantially, but so too does all of the livestock and agriculture. And of course, what happens is that when you burn natural gas, it creates carbon dioxide. And so in terms of the methane emissions, here I've got Australia and New Zealand. You can see Australia at the top there, and I've also got a map as to where these are coming from. And then we're looking these down for Australia and New Zealand on the right-hand side, and we can see indeed the large contributions from the cattle and sheep, but New Zealand has very little, although some gains can be and are being planned for to reduce the values down here. The thing that surprised me here is the substantial fugitive emissions in Australia, which are as large as all of New Zealand's emissions. And this is from leaky mines, abandoned mines, leaky pipes that can and should be cleaned. And so this slide details that and a little bit more as to why some fluctuations occur out, knocks things down, especially in Australia. El Nino events knock things down. And cattle and sheep belch up a great deal of methane, and there's some certain amount from the other end as well. There's also some from diesel in tractors, and there can be some gains, although this is mainly from cattle that are fed in feedlots, and there are some other things that can be done a little bit here. And so methane is much more important than carbon dioxide in the short term. The livestock is about 31% globally, and oil and gas operations 26%. And just today, or the last day in the COP26, there has been a resolution which is agreed to by many countries in order to cut the oil and gas contributions to methane. And that's where the biggest gains can be made at no cost or even a profit, because you then have more natural gas that you can burn. There's very little that can be done in terms of cattle, although this animal is actually wearing a small device that is designed to capture the methane from belches. So there's new technology being introduced. So we need electricity. The issue is whether it comes from fossil fuels or renewables. And surprisingly, there are a large number of people who are opposed to wind power, but they ask the wrong question. The issue is not whether we have wind power, yes or no. It's whether you have wind or solar or hydro or bio or nuclear. And if you're given a choice of having wind power next door versus a nuclear power station, which would you choose? I like this little guy here, which could be mounted on every house. This is a popular little windmill that's used in Denmark. Originally, in this slide, all of these are animated. They're animated GIFs. And so a key issue is decarbonization of and producing a renewable energy system. And so this relates to solar and wind, and the challenge there relates to intermittency. This is something which is missing from all of the plans and the Climate Commission stuff in New Zealand. It's just not dealt with. And so one of the issues then relates to storage using batteries or pumped hydro, which I'll say more about, and transmission from places where you can generate the power to places where you want to use it. And the combination of solar and wind with hydro is actually an optimal one. And New Zealand is ideally situated to take advantage of that and is not doing so. And it requires, however, an integrated system management. So to emphasize one aspect of this is pumped hydro. This turns out to be the most efficient storage system that exists. It's about 80% efficient. It enables you to smooth out the fluctuations. You have times of day when there's a lot of sun and maybe a lot of wind. What do you do with that extra power that people aren't using? Well, you use it to pump water uphill and then store the water that can then drive a turbine and generate electricity at the times you need it. And so this is an especial important combination. And it is actually in widespread use in various countries. New Zealand, Switzerland, for instance, has 6.4 gigawatts of this. Now, it helps if you've got mountains and topography, which New Zealand has, and Tasmania has 8 sites planned or being investigated, as I understand it. The capital costs can be considerable to set this up, but it has a long lifetime. And it's something that New Zealand should be looking at a lot more. In the plans in New Zealand, they talk about Lake Onslow, but it was just for dry year purposes, not for dealing with the intermittency of solar and wind. And it would reduce the reliance on gas and coal. And, in New Zealand, maybe we can get rid of Huntly. And so the conclusions are that I think in New Zealand, there's been quite poor planning for things like alternative cars, vehicles, and bike trails. And there's been a lot of controversy in Auckland relatively recently with regard to bikes can't get over the Auckland Harbour Bridge. More emphasis on solar and wind is essential, and coupling it with hydro as a storage device is potentially very powerful. But there is no system-wide approach in New Zealand. This relates to whether or not the small electric companies can build a consortium, or maybe we should go back to pre-1987 to the NZED, the New Zealand Electricity Department. Also, I put a big plug in for net metering. We had this in Colorado. I had solar power in Colorado, but it's not included anywhere in New Zealand. I don't know what the plans are in Australia with this regard, but this means giving, when you get power from individual houses, you give it back at the same price. And so there is a net gain. And I would point out that a country similar to New Zealand and maybe Tasmania a little bit, they have topography, they have hydroelectric power, and they have actually over 90% electric cars. This includes hybrids and all of their vehicles, and it's just so different. And so the other plug I put in here is that we see the postman going around in Auckland, and they have these electric post carts, which have the advantage relative to bicycles of keeping the weather out. And, maybe every household should have one of these, and maybe we should block out internal combustion engine cars from entering the major cities of Auckland and Wellington, or put a fee on them and have parks of these kinds of vehicles. And so we get rid of internal combustion engines on a much more rapid time frame than anyone is planning for. So a final comment then. Planting and growing trees are great. We should do that. Deforestation is something that's just been addressed in COP26, but that's mainly in the tropics. Offsets are insufficient. We have to cut emissions. New Zealand government has just announced that they're going to cut emissions by 2030, but mainly through offsets. And I think this just does not do it. We have to cut emissions. And subsidies for fossil fuels must cease. This relates to who gets to use certain facilities and land and so on. And carbon pricing is essential, but it must be universal. And this can then be coupled with tariffs, as I mentioned before. And we can start small, but it has to increase. We need to cut emissions of carbon dioxide and methane. And so this is my book, which is coming out in a month or so. If you send me an email. I can give you a coupon for a 20% discount. It deals mainly with climate change aspects and why we have extremes and so on. And you can send me an email to this address. And so, Anika, that's my presentation.
Great. Thank you so much. I'll address one quick, I guess, housekeeping question that popped in the Q&A about the slide deck and whether we can make it available. So reach out to your Jarden contact and we will make any slides that you request throughout the next 2 days available. One question that was sent previously, with countries like Bangladesh contributing only 0.5 tons per capita, meaning they haven't caused the problem, but they're greatly impacted by climate change. Do you think this will be or is a contentious subject at COP26 currently underway?
Oh, yes, that's clearly the case. So small island states, for instance, I was very much involved in that after Hurricane Katrina went through New Orleans in the United States, and small island states in the Caribbean and the Gulf were very worried about and rising sea or either.
I think we're having a little technical difficulty there. We just lost him, did we? Okay. I guess we'll have to wrap it up there. His email was made available, and we can get the slide decks out to everyone. And what we can do is any further questions he'll be able to answer via email. Thank you, everyone. Hi, everyone. Sorry about that. We got Kevin back on. You were cut off in the middle of what you were mentioning about the question in terms of the Bangladesh question about being at a contentious subject at COP.
Yes, so I won't say too much more then. It's going to be addressed there, but it relates to the small countries and small island states, rising sea level problems and so on, that are the victims of experiencing climate change and increased hurricanes and flooding and so on, but really didn't cause it. And so the rich countries then need to set up a fund, a green fund, in order to help them build their economies with renewables uh, rather than fossil fuels, and also allow them, help them build resilience and adapt to the climate change that is already with us. And so that is going to be a very contentious issue in COP26.
Great, thank you. There's another question about going back to your emission slide you had up before. Could you follow up with the questions about who is responsible and if there's a difference between the tree example and exporting coal?
Yes, so that example, I think relates very much to putting a price on carbon. And so if we put a price on carbon, then country A would, and the main way you can do that is when the coal is mined. And so in general, when coal is mined, there should be a price put on it. That makes the cost of coal higher, and that would get then passed on to country B, and country B then may not want to buy that coal, and they may want to use renewables instead. It makes renewables much more competitive. And similarly, if they do use that coal, that there is an increase in cost, and that cost gets included in goods, and so the goods cost more. And so it propagates throughout the whole economic system. And so that's one of the prospects, and how to do that is going to be a major contentious issue. Some countries clearly do not want to have that. Australia is probably one of them. And that relates then to whether tariffs can be introduced in order to penalize countries who do not put a price on coal. And I think ultimately this may happen, and it will put a tremendous amount of peer pressure on other countries. Now, with regard to wood, wood gets used, and trees have a finite lifetime. And so the question is, what happens with trees? Do they get harvested? And if you harvest trees and they get used, then a tree is much more like a biofuel. You shouldn't get any credit for it when you plant it, but you don't get any loss when you harvest it. And so the tree can be used, and it is wood is being used as a biofuel through wood chips of various kinds in various places around the world, especially in the UK. And so probably it gets treated more that way. One of the things about trees are great, and we need to promote reforestation and afforestation. However, as I say, trees have a finite lifetime. An old growth forest, by definition almost, an old growth forest is neutral with regard to carbon dioxide. The trees take up carbon dioxide through photosynthesis and build tree trunks and leaves and twigs. But then the decay of the leaves and the twigs and the old trees that have fallen down on the forest floor put carbon dioxide back into the atmosphere. And an old growth forest is essentially in equilibrium. And so the question is, the best way to take up carbon dioxide is to grow trees, but then you have to harvest the trees and put them in a place, bury them deep in the ocean or somewhere where they are never used and they don't decay and go back into carbon dioxide or methane into the atmosphere. And so this relates to CCS, carbon storage of various sorts, and so this relates also to the whole business of various kinds of offsets, and what the real lifetime you're talking about in dealing with those.
We have another question about the New Zealand government. Do you think they're doing enough to reduce carbon emissions or tackling climate change? You mentioned this briefly earlier about what James Shaw's stance is in terms of offsets versus reductions. Can you speak more about that?
Yes, so yes, I've sort of already addressed that. I think my comments on the last few slides were oriented much more toward New Zealand, and so it relates to the adequacy of offsets and the fact that New Zealand has done very little in terms of promoting solar. There's a certain amount of wind in New Zealand, but there's no offshore wind plan. There's tremendous wind available, and Australia does too, for that matter. Australia has a lot more solar. New Zealand is not capitalizing on the solar the way it could, and that relates to this whole issue that I put on the previous slide of net metering. I think that should be produced. It means that companies can get electricity without having to pay for any infrastructure, which is a wonderful benefit. But the trouble is, small companies don't like this because it's not very manageable because of the intermittency. And so one needs to couple the intermittency of solar and wind with hydro and with pumped hydro in order to have storage devices that are efficient as possible. And none of those are included in any of the plans that I've seen in New Zealand. But, I think we should be able to shut down Huntley on a 10-year time frame and introduce these kinds of measures into the new system.
Okay, we have another question. What are your thoughts on nuclear as an energy source?
Yeah, so nuclear is one thing which is not addressed at all in any of the New Zealand plans, and it has had a very, very good history. But of course, most of the power generation in France for many years has been based upon nuclear, and of course, the nuclear accidents, such as in Japan, have created a very negative view of nuclear, and nuclear waste is a continuing problem, but it's nowhere near as big a problem as it used to be, because now a lot of the nuclear waste can actually be reused and recycled in the new modern nuclear power plants. And so one of the big developments is what are called small modular reactors, SMRs. And these are small, they are modular. You can build an extension on them relatively quickly. They're very popular in Russia. They're very popular in South Korea, and also I think being considered in China. In places like the United States, there are all kinds of regulations which make such devices very expensive. And right now, one of the biggest issues with nuclear is actually the expense. There is considerable expense attached to it. And in the case of New Zealand, then there's enough solar and wind and hydro and other ways of addressing this that nuclear may not be necessary, but it ought to be it ought to be considered. Because these kinds of devices now are quite safe. There's a lot fewer accidents actually overall with regard to nuclear than there is on a lot of other forms of electricity generation. And there is still a bit of a problem, a long-term problem on the nuclear waste that does get generated, however. So it's something that ought to be on the screen, and it ought to be part of the overall playbook. But it has some advantages and disadvantages. At least it doesn't produce emissions.
Okay. I'm realizing we only have about 4 minutes left. It's probably going to wrap up now, so it looks like that's the last question. Thank you again for joining us today, Kevin. And up next, we'll have Matt Keane, the New South Wales Treasurer and Minister for Energy and the Environment. He will be presenting on Energy Infrastructure Roadmap commencing at 10 a.m. Thank you very much.
Thank you, everyone.